Well, I'd like to say that it's time now for something completely different. I was a fairly late addition, I think, to the itinerary at the meeting here. David, are you here? David, there he is. Approached me, 3 weeks ago or so, 2 weeks ago, about coming and presenting. And I said, hey, yeah, what the heck? Sounds like a great group of people. I'd love to come talk to them. But a little bit of a diversion away from the Colorado River and talking about some of the magnificent scenery that we're actually meeting on right now, part of the Grand Staircase physiographic portion of southern Utah. And it also ties into the adjacent Kaparowitz Plateau over to the east, because I'm talking about the geologic history of the region, basically a 260 million year warp speed tour through an amazingly fascinating section of Earth history that's bracketed by cataclysmic extinctions, and I think just so epic in so many ways as you think about it, and it's so well displayed here in this part of the planet. So without any further ado, let me see, should I point it at the... There we go. So the geology of the Colorado Plateau is outstanding on a global scale. It really is mind-blowing what nature has carved and put on display here through erosion and through all the sedimentation that occurred millions and millions of years ago. Of course, you have the Kaibab uplift, which allowed the carving of the Grand Canyon off to the south by the Colorado River and its tributaries. But off to the north, you have this ascending series of cliffs and benches that form a bit of a rising staircase. So you're ascending up through the geologic layers. And as you do, you're also ascending through time. So essentially walking through the Grand Staircase. Of course, there's nowhere to, unless you're a giant, to actually walk through it step by step. But as you rise up through the staircase, you're ascending through time, and you're looking at a story that the rocks have to tell about this particularly fascinating chapter of Earth history called the Mesozoic. So the Grand Staircase portion itself is confined to everything north of the rim of the Grand Canyon, okay? Everything down below the rim of the Grand Canyon is part of the Grand Canyon and represents deeper time and even more ancient history of the region. Not any less fascinating, but maybe a little more foreign and a little harder to relate to. Some of the events that unfold, told by the story of the Grand Staircase, apply to us directly today. And of course, the Grand Staircase, in its alternating cliffs and benches, brings to us some of the most spectacular scenery on planet Earth. You have Zion Canyon here. Okay, the walls of the canyon are carved into the Navajo sandstone, which represents the largest pile of wind-blown sand to ever accumulate on the face of the planet. That's a superlative. The largest sand dune basically ever created on planet Earth. And now it's being reincarnated into sand dunes in other places and carved away into canyons here in places like Zion, and forming spectacular scenery that people come from all over the planet to see. At the top of the Grand Staircase, you have the Claron Formation, which accumulated after the extinction of the dinosaurs and is no less spectacular scenery-wise, but the scale isn't quite as grand as the cliffs you see in Zion. Beautiful, mind-blowing, and amazing in different ways than you see in Zion, but all part of the story told by the Grand Staircase, sort of middle and ending chapters of. So to get an idea, or at least to give you some background or context for what I'm about to talk about, I do want to give you a little geological time primer, because I don't know how many of you might have had geology as an undergraduate, or maybe are actually geologists or interpret geology for a living, but I want to get everybody on the same page, so as I talk about the Triassic and the Jurassic and orogenies and things like that, at least you'll have some framework to hang it in. This is a cartoon geological time scale created in a book called Cruising the Fossil Freeway by Kirk Johnson and the famous Alaskan artist Ray Troll. And it gives you the nomenclature for the basic chapters in Earth history that I'll be referring to. So before the Cambrian, basically, it's a world of bacteria and algae. We're not that interested in that chapter. But those are actually exposed. Those layers are exposed down to the very bottom of the Grand Canyon in selected places. You get the Tapete Sandstone at the base of the Grand Canyon sequence, which dates to the Cambrian, and then moving up through the section, the Permian ends with something called the Kaibab limestone, which forms the rim on the Grand Canyon, basically caps the Grand Canyon geological sequence, and would be the bench or the shelf upon which the Grand Staircase rests. So moving up into the Triassic, Jurassic, and Cretaceous, this is the threefold division of the next major chapter in Earth history, known as the Mesozoic, and the one that will be the focus of most of this talk. Just looking at some of the landmarks, the milestones in Earth history, especially in the history of life recorded in these rocks. The Cambrian records the first seashells or marine organisms with hard parts that fossilize easily. So we start seeing lots of fossils at the bottom of the Cambrian. Ordovician, the first fish. Later on in the Silurian and Devonian, you start to see the first land plants, which are very primitive. Things like horsetails and club mosses appear in the fossil record. Insects, spiders, centipedes, all these sorts of things. First amphibians at the end of the Devonian. First reptiles in what's known as the Carboniferous, the upper part, the middle part, the Mississippian and the Pennsylvanian. That's a key event in the evolution of life because from reptiles comes everything else, including us. Now, moving up into the Triassic, which happened after the largest catastrophe the Earth's ever experienced as far as life is concerned, you see the appearance of completely new and revolutionary types of animals. The first mammals and the first archosaurs. Now, archosaur is kind of an arcane term for most of you maybe, but it includes birds and crocodiles and everything in between. So that's a very important group, birds, bear in mind. Now, after the appearance of birds and mammals, later we see the first flowers and birds appear in the late Jurassic. Okay, so these evolved from their archosaur ancestors, dinosaur-like animals. Actually, dinosaurs. First, placentals and marsupial mammals. Well, that's getting really close to home. The first placental mammals then in the Cretaceous. Then we have another mass extinction that brackets the Mesozoic, and then from there on it gets boring to me. Now, you all may find the Cenozoic endlessly fascinating if you like furry things with warm-blooded metabolisms and producing milk and stuff like that, but I don't really, I lose interest when the non-avian dinosaurs go extinct. But I'll talk about it. I'm not going to gloss over it, okay? So those are some of the milestones that we'll be looking at as we journey through the Grand Staircase. On the other hand, the rocks themselves are recording very specific environments that this region experienced across a span of 260 million years. And their very colors and habits of erosion reflect that. So when we look at the Grand Staircase, and I'll just run through the formations real quickly. We'll go through them in detail, but as we look at the Grand Staircase in brief, we have the Moenkopi Formation at the bottom, which is brick red and forms vast exposures along the Arizona Strip and down around the margin of the Paria Plateau. You have the Chinle Formation, the Painted Desert, of course, beautifully exposed over at Petrified Forest, but also around the Paria Plateau and over near the Paria River Gorge and the Paria movie set over in Grand Staircase, Escalante National Monument. You have the Moenavi and Kayenta formations above that, which are, again, a brick red color. And then back into the Jurassic Navajo Sandstone, the Carmel Formation, which sits on that, which is reddish, purplish, gray, resulted from sea deposits. And then in the Cretaceous, everything gets kind of gray. I jokingly refer to the Cretaceous around here as 50 shades of gray. And that's the reflection of a fundamental environmental shift in the region from drier to really wet. So when you're looking at the bottom of the grand staircase, the brick red colors reflect aridity and extremely high global temperatures. We're in the aftermath of this extinction called the Permo-Triassic extinction that killed up to 93% of all species known from fossils. Think about if 93% of all living things today died. How catastrophic that would be. That would mean even things like cockroaches going extinct, you know. It was devastating. And so the Earth, in the aftermath of that, was literally a hothouse hellscape. It's probably as close to the planet Venus as we've ever come, with the tropics being almost unlivable, okay? So the colors reflect that post-extinction hellscape. Now, eventually, as the atmosphere re-equilibrates and we get rid of some of the carbon and other greenhouse gases that were generated during the extinction, things start to rain again. You start to get better climates. The continents are moving. And so the colors change in the Chinle Formation, reflecting higher rainfall, higher water tables, not as much rusting going on in the irons in the soil. And so the color mutes to purples and blues and yellows and other shades of colors besides this brick red. Again, going up through the next section, and that reflects a wetter time. It dries out again as the continents move north into a low latitude arid belt atmospherically. And honestly, the white cliffs would not be white if it weren't for something that happened long after they were formed. So if the white cliffs had not had hot, chemically leaching fluids pumped through them for vast amounts of geologic time while they were buried down there and turning into rocks, they'd still be red. So their original color was actually brick red, just like the Moenkopi below, and that reflects aridity. That's where you get the giant sand dunes, right? Okay, things wetten up or moisten up again, going into the Cretaceous, and so we return to variegated colors and ultimately to gray, meaning the place was perpetually a swamp or wet, almost like a rainforest. And then let me make one. And then at the very top, Bryce Canyon, of course, returns to pinkish and red, and that reflects a little bit of drying out related to the rise of the Rocky Mountains. Okay, so let's start our journey through the Grand Staircase. This is actually the top of Grand Canyon. That's the Kaibab Formation at the very top, filled with fossil seashells of all shapes and sizes. If you've ever hiked around on top of the Kaibab Plateau, you've seen brachiopods and corals and crinoid stems and snails, all kinds of things, bryozoans preserved, even occasional trilobite bits and pieces in this Kaibab limestone. It was a thriving, subtropical, warm, carbonate seaway, very much like you'd see in the Bahamas today. There's a reconstruction of a Permian Sea. This is based off of outcrops in Texas, but it would have been almost identical here with all the various sponges and corals, and these are brachiopods down here, and then this is a nautiloid, kind of related to the modern chambered nautilus. And you should have it. There's an ammonite there, and there should be fish swimming around, but they weren't actually put into this exhibit. So, I could imagine myself snorkeling in something like this in Belize today. And this is a paleogeographic map done by Ron Blakey showing the basic layout of the land at the time. Now, we'll be seeing a series of these, so I want you to pay attention always to where the border of Utah is. Right, so, here we are in King County. We're well offshore in this shallow carbonate platform, very much like the Bahamas or the Belizean barrier reef today. And the animals on land would blow your mind. These look kind of like dinosaurs, but they're not dinosaurs. They're not even closely related to dinosaurs in any way. They're actually more closely related to us than they are to dinosaurs. These are things called mammal-like reptiles, therapsids and synapsids. They've got 5 claws. They've got the big fangs in their mouths. They're heterodontous, so they don't, dinosaurs generally had all the same kinds of teeth in their mouths. They might even have been furry. That's somewhat speculative, but they may have had some proto or primitive fur on them. They laid eggs, but they were bizarre. And some of them got huge, like this is called a parasaur here. And these things, 12, 15 feet in length. And so the predator, Procolonophonius, also approaching 15 feet in length. So they look like dinosaurs, but they're not. Kind of like Dimetrodon, that classic sail-backed animal that comes in every kid's plastic dinosaur kit. It's not a dinosaur. It's actually more closely related to mammals and very closely related to this animal right here. Okay? So the world was a pre-dinosaur world inhabited by things that by all intents and purposes are heading towards mammals. And then you had a really bad day. Over in the area between Europe and Asia, the Ural mountain area, and east into Siberia, you had the eruption of the largest singular volcanic event on the continents in the history of the planet, called the Siberian Traps. And enough lava erupted out of these vents to cover the entire continent of Europe. And it changed the atmospheric chemistry, and it basically poisoned the oceans. It acidified and poisoned the oceans and sent the Earth into a runaway greenhouse. So in the wake of these eruptions, you had mass catastrophe. A lot of these mammal-like reptiles, or these mammal-like animals, actually perished. They went extinct just at the boundary there and didn't survive into the succeeding Triassic. Well, when you clean out ecosystems wholesale like that, you create opportunities for others, AKA the survivors of this event. And a few things, of course, did squeak through. There were always somebody somewhere was able to manage to hang on through this huge catastrophe. But it wasn't easy. And the Moenkopi Formation pictured here down below the Paria Plateau reflects this hellscape. It was horrible. There's virtually no disturbance of sediment by organisms in the Moenkopi. That's why the Moenkopi is world famous for preserving things like raindrop impressions and mud cracks and all sorts of sedimentary structures that if worms and other things in the soil had a chance to would mix up and destroy because there was nothing living. I mean, it was so hot. There is some seaway deposits within the Moenkopi that do preserve occasional snails and small clams in the area. But for the most part, the Moenkopi here in southern Utah is completely devoid of fossils. And that's a reflection of how bad the ecosystem got in the wake of that extinction. And it took millions of years, it's thought, for the temperatures to come back down and for Earth to become basically inhabitable again through much of the mid and lower latitudes. The survivors were all up in the high latitudes, up near the poles. So this is a Moenkopi map. So just imagine hot, horrible conditions with a shallow seaway like that, occasionally ebbing and flowing over this region. Now, as I said, going into the late Triassic, about 215 to 220 million years ago, things started to settle down. Things started to return to at least livable. It was still fairly warm planet-wide, but things were livable again for larger animals down in these lower latitudes. And so the rocks themselves are starting to reflect, for instance, increased rainfall. These grays and greens and blues that you see at the bottom are the result of high water tables, reducing the iron in the soils and keeping them from rusting. So you would assume that these were high water tables at this point. And in fact, there are coal seams associated with this lower blue-gray sequence in the vicinity where this picture was taken. As you move up section, and those coal mines were used historically by the Paria settlement. As you move up section, this is at the Paria settlement and movie set, guess what happens to the colors, right? They're They're shifting again from the purples and greens and grays back to brick red, and that's reflecting a drying out again of the region, not as a result of volcanic eruptions this time, but as a result of the continents now are shifting northwards into what we call the low latitudinal desert belt, kind of where the Sahara sits today. So the Chinle is full of fossils. It's most famous for its petrified wood. Of course, you can see immense logs of these araucarians, very closely related to the modern Norfolk Island pine and columnar pines that we see in the southern hemisphere today. Well, actually, we see them in Walmart now because they're sold as Christmas trees. But these are antecedents to the modern redwoods. They're a little more primitive in their wood cell structures and cone structures and all that. But they're like a very primitive redwood. They're kind of heading that direction. There were no flowering plants at the time. And look at that change in the landscape. So now it's green. Whew. Something can make a living out there. So you've got these lush, tropical to subtropical conifer forests, not leafy trees, but conifer forests. And in those forests, animals were able to thrive. You have a whole host of different things here now interacting. It wasn't completely dominated by those mammal-like reptiles as it was pre-extinction. You now have this guy. This is a dinosaur, Dilophysis, the very first of its kind in North America. This is a post-osuchid, so it's a non-dinosaur archosaur that's more closely related to modern crocodiles. And then these guys over here, these are actually some of the stragglers, some of the holdovers that survived from that pre-Triassic mammal fauna. So these are dicynodonts that are related to the things that I showed you in the pre-extinction reconstruction. They're like the last stragglers, and they're on their way out. So as you can see, it looks nothing like the tropics today. And this is just a sample of all the different creatures that you would have seen in the Triassic here in the Grand Staircase region following the extinction and the appearance of equable, like livable climate and ecosystems in southern Utah. Most of these animals are not dinosaurs. So if you had to guess, which one the dinosaurs are, your best guess would be to pick the ones that are all bipedal on two legs. So right here and right here and right here, those are the only dinosaurs in the group. Everything else is a crocodile-like animal. So these are all related to modern alligators and crocodiles. Most of them go extinct at the end of this particular period, the Triassic. As things dry out and you start to get lots of wind-blown sand washing into the region or blowing into the region, apparently sourced out of the Appalachian Mountains, it's being carried west from the Appalachians across the northern Great Plains, dumped into areas like Wyoming and the Dakotas, and picked up by trade winds and blown down here into southern Utah and even into Nevada and in eastern California, this gigantic sand dune system. It forms these spectacular bedding sets, that can be tens of meters high. And these are the slip faces of dunes then. So each one of these sets is the downwind direction or the downwind face of a dune marching generally southeastwards across the region. Of course, this is the wave, right? This is one of the most photographed rock outcroppings on the planet. But I put this in here to show you that it's Navajo sandstone and it's still red, right? So the wave still preserves some of that original red color that would have characterized the entire Navajo at one time. And it got leached out of the upper half of the formation, but it's still preserved in its lower half. And it's the interface between where the red's preserved and the upper white where you get some of the really fantastic colors that the photographers go crazy over. So there is that sand dune sea marching towards southern Utah, getting ready to bury it under like 1,800 feet of wind-blown sand. Now, moving up into the later Jurassic, which is a really interesting time because it represents the evolution of the largest animals that ever walked on dry land, both here in North America and on the other continents. You see a return of these variegated shales again, different colors, meaning it's starting to get a little wetter again. So the climate's getting a little more livable. You're starting to see some of the greens and grays that indicate higher rainfall, higher water tables. So we might expect to see some more fossils. As a footnote on the Navajo, it's not very fossiliferous. You wouldn't expect to just go out into the Navajo and find dinosaur bones laying everywhere. Why not? Because it wasn't really a great environment for lots of animals to live in. But following Navajo deposition in the retreat of a minor seaway called the Carmel, you have the deposition of something called the Morrison Formation at the end of the Jurassic. And that is one of the largest bone piles or bone accumulations of dinosaurs on the planet. And it does reach into this area. So the sand dunes are being beaten back. They're being pushed eastwards as things wet up. The climate gets a little better. You start to see river systems now flowing north, northeast across southern Utah. And by some tragic series of geologic uplifts and events, we lost the Morrison over most of south central Utah, but we still have a sliver of it preserved over in the Escalante region, of course, not in the Grand Staircase proper. And we are now finding identifiable dinosaur bones in there. So we know it was here at one time. It just got stripped off between Jurassic and Cretaceous time. Of course, the Morrison contains, like I said, an incredible treasure trove of dinosaur fossils, even in the Escalante area, along with petrified wood there that we see at the state park. And this is up at Dinosaur National Monument, but I'm starting to find sites, not quite of this scale, but certainly of associated animals, with lots of bones in them around Escalante. Oh, and as another footnote, one of the reasons we see so many piles of bones in the Morrison is because of its semi-arid climate. So it would occasionally go into extended droughts, and then these cause animals to die of thirst around diminishing water holes. And then the next time it rains, their carcasses get washed down and heaped up on sandbars and things like that. So you get these enormous piles of bones, like Dinosaur National Monument, like the Burpee site out by Hanksville, which has been mined for bolo ties and stuff for many, many years. And these are some of the characters then that you would expect to see in southern Utah in the late Jurassic. Gigantic predators like Epipantherius and Saurophaganax and Allosaurus. I mean, we're talking about 35 plus, maybe 40-foot giant carnivores. Okay, getting close to T-Rex size. And why do they need to be that big? Because at least some of them were preying on some of the largest animals that ever walked on dry land. Like basically having a blue whale with legs walking on dry land. Some of these animals exceeded 110 feet in length and weighed tens and tens of tons. It's staggering to the imagination. Oops. So we are finding the remains. In fact, I've been able recently to identify bones of this animal, Apatosaurus, from up near Escalante. There really wasn't an extinction at the end of the Jurassic, going into the Cretaceous. You do see a color change, but the animals didn't change super drastically at first. And so really, the only way you can tell that you've gone into the Cretaceous from the Jurassic as you're walking your way up through the Grand Staircase is this radical color change. And here we have the Entrada, which would be underneath the Morrison, a bunch of gravels that used to be Morrison. And then this thing here, which used to be called the Dakota Formation, but it's now referred to as the Natarita Formation from a locality in western Colorado. And the colors are browns, tans, grays, and you'll occasionally see horizontal bands of black, which is coal. And that represents a much wetter climate. Now, this gray here represents a really wet climate because those are marine deposits, and we're underneath, probably 300-400 feet of ocean at that point in the geologic past. So the dates on these rocks here, running about 98, maybe 100 million at the bottom, about 93.5, 94 million at the top of this sequence, and then as you get up towards the Straight Cliffs Formation up here, with the retreat of the seaway, back to about 90 million or so. This is the Kaparowitz Formation. It's thousands of feet up section in the Grand Staircase from the rocks I just showed you, but the same basic gray colors, okay? Like I said, 50 shades of gray. But the bonus that comes along with all those gray colors are lots of fossils, because it's a great environment to preserve fossils. You got thriving animals in lush, wet, tropical to subtropical ecosystems. There's a high biomass, high potential to bury them, and so you get wonderful fossils. Well, that perfect storm all happened here on the east edge of an isthmus-like landmass that was a subcontinent of North America at the time called Laramidia. And Laramidia was separated from the main bulk of North America, here referred to as Appalachia, by an intervening seaway called the Cretaceous Western Interior Seaway. That split these two land masses apart from each other and isolated them for tens of millions of years. And in so doing, allowed completely different ecosystems and animals to evolve on each of the land masses. Now, Laramidia had the extra bonus of forming the very first Bering land bridge. You know, you hear about the mammoths and humans and horses and things like that going back and forth over the Bering Strait up from Alaska to Siberia. Well, it turns out that that bridge first formed in the Cretaceous about 100 million years ago and allowed Asian dinosaurs to come drifting down into North America and sort of take over the place. Well, that really didn't happen to the same degree over here in the eastern landmass, because for a large part of that time, there was no way for them to get over there. So these Eastern Asian dinosaurs and other animals, turtles and fish and mammals and things like that, get over into Laramidia, which at the time would have been much like a cross between Costa Rica and the Pantanal in South America on the east side of the Andes, and they go big and they go crazy. It becomes this amazing crucible of evolution that spawns so many superlatives and amazing animals, it's almost impossible to catalog them all. One of the most fascinating chapters in this region's history, in my opinion. And you also had the rise of this mountain range. It's called the Severe Fold and Thrust Belt, the Severe Cordillera and Orogeny. And you're talking about Andean scale peaks, you know, 15 to 20,000 feet in height, with a big altiplano off to the east, and then a fairly narrow coastal plain on the margin of the seaway. Perfect place to make fossils, let me tell you that. And this is sort of a typical dinosaur site up in the Kaparowitz, off to the east of the Grand Staircase. Something I found, this is back in 2011, but just right on the surface, you can see that's a jawbone, right, with the tooth sockets. These are ribs. This is part of a pelvis, more rib fragments, ribs going into the hill. We ended up uncovering most of this animal and skin impressions. And that's one of the cool things about this region, is we see so many animals preserved with soft tissue because such exceptionally rapid burial was taking place. So based on all the fossil finds in the region, I'm going to give you a quick tour of the different characters that we've seen excavated and named from the region over the last 15, 20 years, starting with the carnivores. This is Lifeforms Argestes. Its name means the southern king of gore, and thank you. And it's actually the oldest true ancestor to T-Rex ever found. So it has the record of being the oldest T-Rex-like animal. This is its descendant, Teratophonius, which occurs in the next formation upwards, about 76 million years old. And it's gloating over the body of a Cosmoceratops. This is Hagrippus, which is an omnivore theropod related to velociraptors. This is an honest-to-goodness velociraptor named Talos samsoni. We've got multiple flavors of these things we call the cows of the Cretaceous. This is a Hypacrosaurus-like animal, just recently documented from the region. But we also have this animal, Gripposaurus, this animal, Parasaurolophus, which has a bizarre tube coming off the top of its head, and one other that I don't have a picture of called Brachylophosaurus, if you want to look that one up. This is now looking at the horned dinosaurs, which are basically rhinoceros equivalents in the dinosaur world. This is Diabloceratops, which again is the record holder for the oldest true ceratopsid or ancestor of Triceratops known. This is Machairoceratops, a descendant of his. It just has his horns all bent forwards, a couple million years younger. This is Nasutoceratops Titus I referred to in my intro. So this is my dinosaur. I'm quite proud of it. I think it's a pretty handsome little devil there. He's feeding with a group of Parasaurolophus over here, and ornithomimid, and gators, and turtles, and maybe some more familiar things. Utahceratops gettyi, named for a friend of mine, passed away in 2017. Cosmoceratops richardsoni, 15 horns on the face gives him the claim of the horniest dinosaur ever found. But dinosaurs were not the top predators in the ecosystem. We actually had this 40-foot-long alligator called Deinosuchus that lived in the lakes and rivers of the region, right here in southern Utah. And of course, moving forwards into the very top of the gray part of the Grand Staircase, we have something called the Canaan Peak Formation, where we would expect to find T-Rex proper, the true tyrant king of the dinosaur world and one of the largest predators to ever walk on dry land. There's a herd of Edmontosaurs in the background, and he's stalking. We would have definitely expected to have these animals living here. They've been found just north of here up in the Ephraim and Manti area. Thank you. And of course, 66 million years ago, the Grand Staircase and other places record the dinosaur world came to an abrupt end. Unlike the Siberian event that triggered the Permian mass extinction, this one appears to have been volcanoes in India overprinted with a gigantic impact from outer space. So we actually have the smoking gun of the impact down in Mexico. You may have read and heard about this extensively, but it's unequivocal that we had both triggering extinctions. All of this recorded right here in southern Utah. And you can see the change from gray to the pink cliffs of the Claron Formation also spans that extinction event. So the extinction event is recorded right here at the base of the Claron Formation. And we may actually have it. Thank you. Now I kind of lose interest, so, but I don't have much time, fortunately. So you get into the Claron Formation, whose red colors reflect now the rise of the Rocky Mountains. Prior to this point, the whole region had been somewhat flat and at or below sea level. But now the Rocky Mountains and the uplift of the Colorado Plateau has started creating rain shadows that create local aridity, and that's reflected in these red rocks of Bryce. Here's a reconstruction then of Bryce Canyon geography. So these are big lake systems just to the south. We're down here in King County. You're on the margin of that in an interior basin. And then Brian Head Peak records, this is one of the highest points in the southern plateaus, very tippy top of the Grand Staircase. You get volcanic rocks representing gigantic eruptions along the Nevada-Utah border area, smothering the whole region with ash in this sort of proto-Rocky Mountain area. And then bringing us to the present, we now find mammoths and other Ice Age animals buried I will. For instance, in the big water area, bringing us to today, and I will leave you with that inspirational message that dinosaurs are still here. So I hope you've gained an appreciation for the breadth and the importance of the story that the rocks in this region tell of our planet's past. So thank you very much.